So I'm very excited to introduce Nissim. He is a community member from React Native, but we've brought him over into Rustland. So please give him a massive, massive hand.
Awesome. Thanks, Ernest. Yeah, really excited to be speaking here today. So I'll be talking about how to integrate Rust into the JS ecosystem. Just quick introduction. So I'm Nissim. I've been a full stack developer at Theodo for almost 2 years, and letting Rust on the side kind of almost as on, using it on for personal projects. And yeah, because I work mostly on like web and mobile full stack projects, I've been trying to find ways to unite the two and like incrementally adopt Rust into existing projects when our clients, we're a consultancy, but our clients might not want to go full on with Rust, or like might not want to take that risk. Yeah, and that has only a bit of a reputation. So this is a meme that my colleague actually sent me, which is very fair. Cool. So what's this with Rust on NPM? Well, actually a lot of big projects in the JS ecosystem have been using Rust. If you're using TurboRepo, SWC, or like oxlint, or any of the oxc tools, they're actually built in Rust, and they're like a core part of modern web development. So like SWC is part of Next.js. TurboRepo is also built by like Vercel and some really big projects adopting Rust in the JS ecosystem, basically. So why would they make the switch? Well, the kind of obvious reason is just performance. For example, oxlint, which is an ESLint replacement, so like a linter for JavaScript, boasts up to like 100 times the speed of ESLint. So like with that kind of number, it's quite easy to justify it. And similar story with SWC, which is a compiler for like a transpiler for JavaScript. So just better performance. But actually, when you look at TurboRepo, which is originally built in Go, and then they wrote a really cool article that I recommend you check out, which is why TurboRepo migrated from Go to Rust, where they explained that actually what mattered to them was more the stability and like the access to the low-level correct APIs. So like for example, file system permissions, very different on Linux, on Windows. Go didn't have like very good abstraction for those, so they ended up having a lot of errors like at runtime on users' machines. Whereas with Rust, they can catch those errors early in like at compile time. And it's a similar thing if you have to use like a native library written in C or something like that. It's going to be much easier to use that if you're using Rust rather than JS. Cool. And then kind of the point of like where this kind of goes into this talk as well is portability. So by writing a tool in Rust rather than JS, you're not reliant on Node in order to run it. So why this matters is if you have a user base that's spread across multiple ecosystems, for example, I don't know, you're writing like a generic tool that people on Python want to use, maybe people on like the JS ecosystem, people in Rust, you can write it once. And then because it's just a self-contained binary, you can very easily publish it to multiple registries like NPM, Homebrew, Crates.io, Python, like PyPy, I think it's called. So you like write it once and then serve all of those users just seamlessly. So hopefully all that makes sense. And just gonna show you quickly what we're building today. So it's a RM replacement. I've chosen a very simple project just to be like focus on the more just to focus on the integration basically with NPM rather than building a really complex tool. So as you can see, I've just used my tool through npx, which is like a way to like download and use a JS package, and I've just created the file, deleted it, simple. And kind of what motivated me to do this initially was there's this equivalent tool called Rimwrap, which is like an RM replacement which works cross-platform. So you might have seen it in some like package.json scripts, build scripts, in order to like clean up some folders. You want to use Rimwrap because maybe some of your team are on Windows and they can't use RM. That's kind of like why it exists in the first place. And I thought, oh well, it seems like simple enough. I can rewrite it in Rust and hopefully have better performance. As you can see, it's not that exciting in terms of performance, actually. So in blue, it's the actual elapsed time in seconds, and then in red is the CPU time, so the CPU usage, kind of how efficient the program is. My version is like 15% faster, which is good, but nothing crazy. Actually 4 times more efficient in terms of CPU, which is cool for some use cases, I guess. But yeah, I guess the moral here is measure, don't just assume that it's going to be faster just because it's Rust. In this case, the file system is like the main bottleneck. But anyway, here's how we build a CLI tool in Rust. So I'm using this great library, which was called Clap, and it makes the process really simple. Because what it lets you do is declaratively create your CLI by just like creating a data type. So in this case, I care about 4 like arguments, which is whether to delete directories, whether to delete things recursively, whether to ignore files that were not found, and then just a list of files that I want to delete. So I just created like a normal struct declaration. And then with the power of macros, I can add a bunch of like metadata, such as documentation strings, which actually end up in the help output, whether to take arguments as like a short form, so that would be -d, or long form, which we don't have here. Yeah, so I think this is kind of another benefit of using Rust is there's like good tools for building tools. And yeah, it's just very pleasant to work with. So just having that and then a simple line of code, we actually get a fully functional CLI, so that can like be done in half an hour, or maybe less. Yeah. So, and then, oh, sorry. The core logic is really simple, so I'm not going to go over it too much. But basically, we just want to remove files, remove directories, and we use the standard library for that. Don't worry about the details. It's just, yeah, standard library functions. Cool. Now we have a tool. We want to set up all the infrastructure that we're going to need so that it can be published on NPM. So the setup I've got here, I hope this is readable, is we have a base package and we have some like a bunch of platform specific packages. And the kind of reason for that is because you're writing like binaries targeted for one operating system, one CPU architecture. We actually need people with like different platforms to install different things, right? So if, as a user, I'm going to install the RMRS package, but actually the implementation that I get is going to depend on what machine I'm running. So the way this works is we have these optional dependencies, and they're just like normal dependencies, except if the package manager fails to install it for whatever reason, then it will just skip the dependency rather than throw an error. And in this case, if you see on the platform-specific packages, we actually have constraints on the OS and CPU that can run the package, so that, yeah, your package manager will know if the package is applicable to it or not. And then we have this little like binary entry, which tells the user how to execute our like tool. And it's actually this wrapper script that I'm going to go in more detail over in a few seconds. But yeah, we have a wrapper script on the base package, and then the platform-specific binaries in the platform-specific packages. Cool. So what does the wrapper script do? And I guess, why do we need it? Well, we need like a platform-independent way of entering into our program. And the way we do this is, well, because we're using NPM, we know that the user has Node.js, so we can just write a simple JS script. And the 2 responsibilities it has are finding the right package name and like executable path to execute, and then just running that with the right arguments. So here we just have this function, which really what it does is like put together the name of the package, the operating system, the architecture, and then resolving that into a path, which is going to be somewhere inside your node modules usually. And yeah, just returning that basically. And once we know where to like what to execute, we can just spawn a new process with that package, and we pass it down any arguments that we got from the like before from the user. And at the end, we exit with whatever status we received. Cool. So we've got a Rust CLI. We have a way to run it on like as an NPM package. The last thing that we need to do is just publish it, basically. So there's 2 components to this, and one is CI. So For example, I'm developing on a Mac. I'm not going to have the opportunity to test my tool on Windows necessarily during the development process. So I don't really know that it works. Rust is great because usually when it compiles, it works, but you do want to have a bit of like additional guarantees. So I just built a really simple like CI pipeline, which actually runs on all of my target architectures. And that's important to just catch bugs earlier. So I run the same tests on macOS, Linux, and Windows, and I run a bunch of things like checking for formatting, checking linting with Clippy, checking that it compiles, and then running some unit tests and integration tests. And that gives me a lot of confidence that my package will work anywhere that it can be installed. And then the slightly more error-prone bit, or like the bit that I had to like iterate over lots of time, was the continuous deployment setup. So because the setup, the like package structure is quite weird and unusual, if you try to publish it manually, you're going to like have a very bad time basically, because you need to compile all your packages, put them in the right places. It's just a lot to do manually. So having a good CD pipeline is going to make this a lot less painful. And at a high level, what I need to do is build all of my platform-specific binaries. So in this case, I'm supporting, for example, M1 Macs and then Windows PCs. So that's like 2 parallel jobs. Actually, each of them run on different operating systems. And once I've built all of my binaries, I can then download them into a different job, which actually generates the packages on the fly. So by that, I mean, instead of manually writing down, if we go back a little bit. So instead of having to manually write down all of these like package.json declarations on the right, oh, that's my right, on the left, depends on one. Yeah. Instead of having to do that manually, I actually generate it from the template, and so it's a lot less burden on the maintainer. And then once I've got all of these packages generated, I copy all of the files where they need to go, and then I can finally run npm publish, and that's basically it. With like a few learnings along the way, like Windows is weird and it uses different extensions, so you have to keep that in mind. Yeah, small things. And I also, just for the fun of it, published to crates.io, which is very simple. Just one command, basically. And that's basically it. So my key takeaways would be, well, Rust is taking over the JS dev tool ecosystem, whether it's for performance, for like stability, and for like portability reasons. But actually, even though those are really like big, well-established projects doing it, it's quite easy to do it yourself and try it on like an internal tool if you want. So I definitely recommend doing that if you have any ideas, like, I don't know, some kind of compiler or linter or like plugin that you could use on your project. And if you do it, I'd highly recommend automating the build and release process as much as possible, because like, for example, things like keeping the versions in sync between the Rust side and the JS side, you don't really want to mess that up. And so it's better if you have like a good process with scripts. And I also have to acknowledge this really good blog post by the author of Gitcliff. So Gitcliff is just a tool that lets you generate changelogs, and they actually built it in Rust, and they published it to like NPM, crates.io, PyPy, and lots of other places. And it's like really shown how universal Rust is in terms of building tooling for programmers. So yeah, definitely recommend reading that blog post. It goes into like similar stuff that I did, and shows like a lot of pitfalls as well in the small details. And this is the package on NPM if you want to see what it looks like. Hopefully it looks like any other NPM package, basically. And there's the source code as well linked in there. But yeah, that's it for me. Any questions?
Oh my god, I caught it. Sorry, so the root npm package and then like the optional dependencies. How does npm decide Like which of these optional things is going in? Missed that.
So do you mean when you install the package?
If
Which
I
one?
install rm-rs,
Yes.
how
So
does it
it's
decide which one?
so it will try to install everything in the optional dependencies.
Oh, everything.
Yeah, it'll try to install everything, and then when it's trying to install, for example, like the Mac OS ARM64 version of it, if it sees that you don't have the right like OS or the right CPU architecture, then it'll just print a warning and then move on to the next one. And actually, it doesn't actually end up on your file system. Yeah.
Oh,
Hi, thanks for the talk. In terms of the continuous deployment, you talked a bit about automating it. How exactly are you doing that? Is there some kind of library out there that sort of does most of the hard work for you, or did you have to do it all yourself?
So in this case, I did a lot of it myself. I could probably, for example, on the release process side, I just built like a simple bash script, but I'm pretty sure there's good libraries for like automating release processes. I guess because I have like a slightly weird use case with like keeping the like cargo tunnel and like the package JSON in sync between like the Rust and the NPM side. I wasn't sure if I could find something like out of the box that does that, so I went for a custom script. But definitely check out some like yeah. I can go into more detail if you want, but it's like not very like showing you the GitHub Actions pipeline is going to be a bit dry and like yeah, it's a bit hard to go through.
Thanks for the talk. In your experience, what one thing would you bring over from JavaScript development experience over to Rust? If you could click your fingers, what would it be?
In terms of, as in like what kind of tool would I migrate from? Okay.
As in, yeah, just in terms of your developer experience, when you work in JavaScript, you really like using X,
Right.
and you don't have that X in Rust or like an aspect of it.
I more often have the opposite problem, to be honest. Things that I miss from Rust in JavaScript. Yeah, I guess I haven't really worked with like Rust front-end frameworks that much, but I know that the like hot reloading stuff is very behind like JavaScript, for example, having to like recompile your whole server if you want to see any changes. So probably, but I don't really see that. I don't know, maybe I'm being pessimistic. I find that hard to see in the Rust world.
Thanks for the talk. On a higher level, I think I've been listening to a lot of podcasts where they feature people who have built some core library in Rust and then add wrappers around that, whether it's IO3 or bindings JavaScript. But something that eventually crops up a lot of the time is that when you have a large enough like API surface area, it actually makes sense to migrate some of that to the language that is wrapping the core library. You see this with projects like Polars, and I believe the one from the podcast that I'm quoting is Timely Data Flow or something like that. Do you feel like this is something that would probably happen in the JavaScript ecosystem too?
So just to summarize, like if you built like for example a WebAssembly library and then actually added like a bunch of features on top of it in the JavaScript realm rather than in the Rust realm. I think so, and I think the reason for that is like some of the JavaScript, like basically you have to build something with in the mindset of your users and your target audience, and the target audience of like JavaScript developers doesn't expect the same kind of APIs as like the Rust audience, and maybe it makes sense to have it all written in Rust, but then you have like a thin layer that's translating, but maybe doing a bit more than translating on the JS side. So yeah, I think that makes sense in terms of an approach.
Any more questions? Any more questions? All right. Please give him a very big hand.